Today we're going to take a look at some vector application problems. So those of you that are in physics, please try to help out those that are not in physics. And I might do it a little bit differently than your physics teacher, Mr. Hellman, and that's totally okay. But this is the way that I'd like you to represent them for our math class. So let's take a look at the first one. 3 workers, Mr. Paston, Mr. Sauer, Mr. Carlson, are pulling on ropes attached to a tree stump, as shown in the diagram that you've got right there. Find the magnitude and the direction of the resultant forces on the tree. So keep in mind that while it's a 3D picture, it's a 2D diagram. So it's kind of like looking at an aerial view of it. We've got one vector, Mr. Paston's, that's 60 newtons. Remember, that's the magnitude. Mr. Sauer's vector is 35 newtons. And Mr. Carlson's vector is 40 newtons at a negative 60 degree angle marker there. So what we want to do is first write the component vectors of each vector. V sub 1, V sub 2, and V sub 3. And I'm going to label those. Let's put those 3 vectors on here. We'll make Mr. Paston's V sub 1, and his vector is straight up. It's 0 degrees, or 0 left or right, but it's 60 up. So 0, comma, 60. It's 60 units in the vertical direction. Mr. Sauer's vector we'll call V sub 2. Let's see if we can fit that in there. And that's 35 newtons, and it's only horizontal. So that means we are at 35, comma, 0. Pointy brackets. Those are our component vectors. Mr. Carlson had to be difficult and gave us a degree angle of negative 60 degrees, 4th quadrant. So cosine's positive, sine is negative. So we've got to find those horizontal and vertical components. Take a minute and figure those out. So again, we've got 40 times the cosine of 60, negative 60 degrees, positive 300 degrees for our x component, which is 20. And then we've got 40 times the sine of 300 degrees or negative 60 degrees. So that gives us, and what you should have gotten, negative 20 times the square root of 3. So our resultant that we're looking for, its components are the sum of all the horizontal components and the vertical component is the sum of the 3 vectors' vertical components. So we're just going to simplify that off. So we've got 55 and 60 minus 20 square root 3. We've done this many times in the last couple days. What I want you to do is pause the video right here, find the magnitude of the resultant vector and the angle. All right, so let's take a look at that. We've got our resultant by taking the square root of our horizontal component squared plus our vertical component squared. So that's about 60.565 newtons, because that's our label. And then we have to find our angle. So we've got theta equals the tangent inverse of our y, our vertical component, over our x. So opposite over adjacent. So 60 minus the square root of 3 over 55. And then we just want to verify what quadrant that's in. So I have a positive x, so I'm looking at 1 or 4, because it's positive 55. And then 60 minus 20 times the square root of 3. Well, 3 is smaller than 4. The square root of 4 is 2. So this is under 40, which means this, the y value, is positive, which is telling me I'm in my Q1. So my x and y are positive. Q1, I don't have to worry about my angle for my tangent, so I can plug it in my calculator and get 20.753 degrees. So that's the direction that that stump is moving. And luckily, no one's in that direction. So if the stump gets out, they're all safe. Let's take a look at the next problem that you have. Darth Vader Sauer has a force of 36 newtons and pulls on an object at a bearing of 70 degrees east of north. Mr. Burke pulls on the same object with a force of 48 newtons at a bearing of 48 degrees west of south. So find the magnitude and the direction of the resultant force. First thing that we have to do is rewrite each of these, and we might want to sketch a picture just to make sure we're on the right track. So please do that. Pause the video right now. So your picture should look something like this. 70 degrees east of north, that means I'm 20 degrees above the horizontal axes, and then 48 degrees west of south means I'm 42 degrees this way, which means altogether that's 222, because 42 plus that 180 gives us 222. So now that we have our component or our picture right, pause the video and write the exact components for each of our vectors, Darth Vader Sauer's vector and Burke's vector. So here are those components, and we have to find the resultant. We want to find what's going on here. So we take the x values from Mr. Sauer's vector and the x value from Mr. Burke's vector and add them together. And I'm going to store that in my calculator as A. You guys should be getting pretty good at storing stuff. And we're going to take the y component of Mr. Sauer's vector plus the y component of Mr. Burke's vector, and we're going to add them together. And we're going to store that in our calculator as B. So if you did that correctly, we can find the resultant. So pause the video, find the resultant, and find your angle. Looking at the values of your resultant is going to help you determine what you need to do for your angle. So here they are. Here's our magnitude and here's our angle. And it's 264.687 because my horizontal and vertical components are both negative. So if those are both negative, that's telling us it's in quadrant 3, which means we have to add 180 to our answer that our calculator gave us for the tangent inverse of B over A. And if you want to be an all-star, you can put it in terms of the bearing, because that's how we were given both of our angles. So since it's super close to 270, I'm just going to take 270 minus our angle, and that's how many degrees west of south we are, 5.313 degrees. Let's take a look at the next problem. So Pirate Pete, who works for Mater's Towing, has his tow truck hooked up and is pulling a stalled car. So what I'm going to do is I'm going to move Pete and Mater so that they can tow a stalled car. And I'm going to put that car over here. So there's our car. It says the cable makes an angle of 50 degrees above the road. So we're going to draw our picture in. That's where cars get hooked up. So it makes an angle of 50 degrees on the road. If the tension on the tow truck's cable is 1600 newtons, how much work is being done by the truck to pull it down the road 1.5 kilometers? So we're going to put some measurements in here. This is a 50 degree angle. We've got 1600 newtons. And what we're doing is moving it down 1.5 kilometers. So there's a couple different formulas that we can do with this for work. In order to find work, which is what we're asked to do, how much work, we can do that by taking the magnitude of our force vector and multiplying it by our distance. We can also take work and take the force vector and use the dot product times our distance vector. So I'll show you what both of these look like in terms of this problem. Well, if we're finding the force, the first thing we need to do is identify this vector F. And for identifying it, we have to find the components. So we've identified our force vector. We've got 1600 times the cosine of 50. And we've got 1600 times the sine of 50 degrees. So looking at that, we also want to write the vector for how far we're going down the road, because this in itself is a vector. So we've got to use the label of Newton meters. So it says change to meters in our directions, and that's what we're going to do. So 1.5 kilometers in the x direction would be 1,500. We're not moving vertically. The car's not jumping off the road. It's not going up or down. We're just making it travel down the road. And this is the direction we have to be working, so that's the direction I've got. So if I'm going to find the dot product of this, I'm going to take the x values and multiply them. So 1,600 cosine of 50 degrees times 1,500. And then we're going to add 1,600 times the sine of 50 times 0. Super convenient. And we're going to plug this in on our calculator. And we'll just round it up to the nearest Newton meter, because why not? The other way that we can do it is using this formula. So since we're talking about that horizontal movement here, we can also talk about the horizontal force, and that's our force that we're implying with the magnitude of this. Just the horizontal force to figure out how much work is being done. So if I took that horizontal part, squared it, then I just get 1,600 times the cosine of 50 degrees times our distance, how far we're traveling, 1,600. I said it again. Sorry, guys. Times 1,500. And we're going to get that same answer. And for this one, why not? We'll be exact because our calculator does it so nicely for us with 3 decimal points. 263 Newton meters. I know that this is tricky. I know that you might not be super great at this for those who haven't done certain problems like this in physics. Give your worksheet a shot and work together to try to solve these problems. And I will see you on Monday. Those of you that are staying after school to take a test, I will be back for you. So I'll see you then. Otherwise, have a great weekend.